racing. I'm going to talk to you today about who's ESR. Some of you may have heard this organisation. We're a Crown Research Institute that powered the scientific response to COVID. All of the wastewater testing, the genome sequencing, all the data that was going to those stand-ups that were occurring every day at 1 o'clock came from ESR. And I want to talk a little bit about some of the things that we do. It's not only COVID. So I want to start with forensics. So we hold the police DNA database. So these are people who have been compelled to give us a DNA specimen, and if there's a crime committed and the police get some DNA, they send it to us to see if we create a match. And about 4% of all New Zealanders are on that DNA database. And if we get a specimen from a serious crime brought to ESR, there's actually about a 70% chance that we'll be able to tell the police who committed that crime. Here, on the 2nd of December 2018, on her 22nd birthday, in this downtown Auckland hotel, the British backpacker Grace Millane was murdered. And it's ESR as an organisation that has our staff, our forensic staff, go and analyse that crime scene and subsequently present evidence in court. We also look after all of the drug analysis in New Zealand, including methamphetamine, about the population of Tauranga users or has tried methamphetamine in the last year. And we do the analysis of all of the customs and police seizures. We also do some other things which I'll cover briefly. Drinking water, so the cryptosporidium outbreak that you may have heard of in Queenstown is us. We look after food safety, and we also look after radiation safety for New Zealand, the safety of those CT scanners and other things in our hospitals. And here's something that we've done that's a bit innovative. If you imagine it's 1 a.m. Saturday night, there's a red falcon doing burnouts at an intersection in Auckland. The police turn up and they pull the driver over. They do a breath test, and that breath test is negative. But they notice a small bag of white powder in the car, and they ask the driver about that, who claims that it's coffee sugar. And the police are in a situation where they can't prove that one way or the other. And so here's a device about this big that they can pull out of the boot. They can put that sample on without even taking it out of its plastic bag. That device connects to their cell phone, goes up to a computer with artificial intelligence, and within a few seconds it'll come back and display on that cell phone methamphetamine or cocaine. So this is taking science to the community rather than bringing the specimen to the scientist. And here is the scanner. It's called Lumi. You can look at it, look it up on the internet, and it's this new way that police on the front line can immediately determine whether this is a drug of interest. And it's changed the nature of the conversation. If there's just a small amount, the police will say, well, it's methamphetamine, and they'll say, what about taking a health route? This is a health problem, not a judicial problem. Rather than talking to the judge about this, what can we do from a health perspective? I mean, if they've got 20 kilos in the boot, it's going to be a different kind of discussion, but it's changed the discussion for the police. I want to talk about this situation with 1080 in the milk powder. You may recall, way back on the 21st of November in 2014, there was a letter sent to the head of Fonterra, Teo Spearing at the time, an anonymous letter. It also went to Federated Farmers saying, if you don't stop using 1080, I'm going to put it in baby infant formula or milk powder. And just to show I'm serious, here's a sample in the letter. And this really impacted. It was taken very seriously. And so at ESR, we were asked, first of all, well, is there 1080 in this or not? And we analysed that sample, and there was enough 1080 in there to kill about between 15 and 20 infants. So that made it a serious threat. So we then had to think with the police about what the next way forward was. So, the situation, 36 police officers worked full-time on this investigation, and there were about 40,000 tests of milk powder to see if any of those had 1080 in them, and all of them were negative. The supermarkets started putting baby infant milk powder under lock and key. And there had to be a halt in trading, some of you may recall, with Fonterra, Synlait and A2. In fact, the spot price for dairy products dropped by 8%. And the police at that stage had a list of 2,600 suspects. They included eco-terrorism, people that may have had mental health issues, political or other groups, but 2,600 suspects was difficult to narrow it down. But there was a breakthrough, and the breakthrough occurred when a second letter was sent to the detective looking after this case. And that second letter says, nothing to worry about, I'm not going to take this any further. And we thought, well, could we get some DNA off that letter? Now, they haven't licked the envelope, they've just touched the envelope. They've touched the envelope that has then gone through the mail system and been delivered to the detective's address. And what we did at ESR is that we took that letter and swabbed it for DNA, and we were able to find about 10 cells. So for those of you who are biologists, that's not very much. And from those 10 cells, we were able to get a DNA fingerprint for the person who'd sent the letter. It was actually more than one person fingerprint on the letter. There was the police officer who'd opened the letter, no surprise there, and there was a third unidentified person who we never were able to identify. And it turned out that one of the person's DNA on there had volunteered some DNA previously, and ESR was able to match the DNA on the letter to suspect number 1391 as being much more likely to be the person who posted the letter than a random male from the population. So what happened? The suspect was subsequently convicted. His name was Jeremy Kerr. He was a 60-year-old man, and he owned a pesticide business that was in competition to 1080. And here is his, some of you may know it, Ferrotox, and he was receiving royalties from this product. And the royalties were about $100,000 a year. Actually, they'd been declining with the use of 1080 from about $250,000. His lawyer said that he was never going to put 1080 in milk powder. Of course, the police didn't know that at the time. And that meant that, of course, he actually had some difficult personal circumstances. His wife had died from cancer. But he was sentenced to 9 years in prison for this and was released on parole in 2020. In fact, as part of this investigation, not only did ESR contribute to that tiny amount of DNA from touching the letter, but we also analysed the 1080. And all 1080 is the same chemical formula, but there are some subtle differences for the scientists out there, some isotope differences, and we keep track of every import of 1080 into the country. So we were able to match it to all the samples from every import batch and isolate exactly which import batch it had come from. We were then able to look at the people who had received or picked up 1080 from that batch, and surprise, surprise, Jeremy Kerr was one of those people. He told people that he didn't think it would be taken seriously, but ultimately the financial motive for the 1080 and milk powder was a financial or business motive. I want to talk briefly about DNA, and this is what DNA looks like. It looks like a string with beads on it, and the beads are different colours. There are only 4 colours allowed, And so when we were doing the sequencing of COVID, all we were really doing was looking at COVID's DNA. It's actually RNA, which is a close relative, and all we were saying is the order of those 4 colours. That's all we did. And because the COVID virus would mutate or change, it would mean that one of the colours, in this example, that should have been purple, is now yellow. And that's all a mutation is. It's just a substitution of one colour for another. Sometimes there are other mutations, such as one of the beads being missed out, for example. And so that's what we were doing when we were sequencing the genome. Now, COVID has about 30,000 beads. And go on. And this is what the genome looks like. It's just a list of the colours, effectively. The human genome has about 3 billion beads. And it may come as a surprise to you that Pinus radiata has about 10 times as many beads as the human genome. We're not the species with the longest amount of DNA. I just want to talk very briefly about wastewater testing. A lot of really good health information goes down the toilet every day. If we want to know who's got COVID, we can do diagnostic tests, and you will have all done them, but actually we can just look in the wastewater. So we produce about 1 billion litres of sewage every day, and that COVID virus, about 1 million would fit on the head of a pin. So we're looking for something that is incredibly tiny in 1 billion litres of sewage. We showed that if one person had COVID and it went into the sewage treatment, and then 10,000 other people who didn't have COVID contributed, we could still detect that person. So we were first asked, is there COVID in the wastewater? Yes or no? And then as COVID became more common, we were asked a different question: how much COVID is in the wastewater, and is it going up or down? And then finally we were asked, well, actually which variants, which mutations are in the wastewater? And here's some of the results. So what we're looking at here goes back to March 2022 and pretty much up to date. And the top line, the greeny line, is the wastewater, and the blue line is the number of reported cases. And you can see that the number of reported cases and the wastewater track pretty well together. Until recently. And now we see that the number of reported cases is kind of going down, and the amount of COVID in the wastewater is going up. So this brings us more or less up to date, I think the end of October, and we are seeing that the COVID rates in wastewater are climbing, but we're not having them reported as you might expect. My final slide, we also look in the sewage or wastewater for drugs. And this is just an example over a few years of methamphetamine use in New Zealand. The top line there happens to be Whangarei. I think the next line down is Auckland, and the green line is Christchurch. And you can see that there's actually quite a lot of difference around New Zealand in drug use. If we change to cocaine over the same time period, you can see that it's Auckland that is leading the charge on cocaine, and we see lower rates in Christchurch and in Whangarei. We also see quite a lot of variability by day of the week. So weekends, they peak, and if you were to go to the University of Otago during the orientation week, when many students are turning up for the first time, we always see quite a significant peak in MDMA, which is ecstasy or one of the party pills. And by getting this data, we can help the police understand whether they are seizing a very small amount of the drugs coming across the border or whether they're making a material difference, because we know approximately what the usage is in the communities, and they can look at that against their seizures. My time is up. Thank you very much. A little bit of information about ESR. Ka kite.